Today we are going to discuss about the basic pharmaceutical calculation along with the ratio conversion, percentage fractions, alligation methods, proof spirit and isotonicity, which comes under your assignment number 5 from diploma first year as per the new PCI syllabus. So we start. Initially, whenever going for your concentration term, the concentration is the quantity of solute which is dissolved in a given quantity of the solution, and it is expressed as concentration of solute per concentration of the solution, and the concentration of solution can be expressed as percentage concentration, and the concentration of any solution in percentage means the amount of solute that is present per 100 ml of the solution. And there are four methods of expression of percentage concentration in case of pharmaceutical solutions. These are percentage weight in weight, percentage volume in volume, percentage weight in volume, and percentage volume in weight mode. So coming to the first mode of expression, that is your percentage weight in weight, and it is defined as the numbers of grams of solute that is present in 100 gram of the solution, and is expressed as percentage W by W symbol. For example, if you are going for a solution which is expressed in percentage weight in weight mode, that is 20% weight by weight of KCl solution, that means in that complete whole of the solution of KCl solution, there is 20 gram of KCl present in every 100 gram of the potassium chloride solution. Similarly, in general, the percentage weight in weight mode of expression in case of pharmaceutical solution, it is very rarely used, as we are consuming the solutions in terms of volume, not in terms of weight. And for this reason, in general, the percentage solutions of solids in liquid are not made in percentage weight in weight unless it is specially required. For this reason, the percentage weight in weight mode is not commonly used for solution terms, but in some of the cases it has been used when it is specially desired. Okay. Let's see. For example, if we are going for a percentage weight in weight expression which contain phenol 160 gram along with glycerin 840 gram, which produce your 1000 gram of preparation. So in 1000 gram of preparation, phenol concentration is 160 gram, so that in 1 gram of preparation we can get 160 by 1000 gram of phenol content. So in case of 100 gram of preparation, phenol content is equal to 160 by 1000 into 100, that is equal to 16 gram. Hence the phenol glycerin contains phenol that is 60% weight by weight of glycerin, and we have weight per ml of glycerin is 1.26 gram. That is, in 1 ml of the glycerin we have 1.26 gram of the glycerin content. Similarly, in 100 ml of glycerin we have 126 into 100, that is equal to 126 gram, and the quantity of phenol required is equal to 160 divided by 840 into 126, that is equal to 24 gram. Hence, to prepare 100 ml of phenol glycerin IP, the formula will becomes phenol taken is to be 24 gram and glycerin should be taken, that is 126 gram, to prepare a 100 ml of phenol glycerin IP in terms of weight in weight. Okay. Next, coming to the second mode of expression, that is the percentage volume in volume mode. It is defined as the volume of solute in ml which is dissolved in each 100 ml of the solution, and the expression should be percentage V by V, and the volume in volume percentage is made when the solution is made by mixing the two liquids. For example, 80% volume by volume alcohol means 80 ml of alcohol is present in 100 ml of the solution. Similarly, another expression is there to prepare 200 ml of 5% solution of chloroform in 95% alcohol. That is 1 ml of chloroform dissolved in 100 ml of alcohol. We have that is termed as 1% volume by volume. That means 1 ml of chloroform is present per 100 ml of the alcohol. That is 1% volume by volume solution. In case if you are going for 5 ml of chloroform when dissolved in 100 ml of alcohol, that is equal to 5% volume by volume solution of chloroform in 100 ml of alcohol. Hence we have to prepare as we have to prepare 100 ml of solution, 5 ml of chloroform is required to dissolve in 100 ml of alcohol. That gives your 5% strength, 5% volume by volume solution. That is 5 into 2, that is equal to 10 ml, and 100 into 2 is equal to 200 ml. So for 200 ml of preparation, we need to add 10 ml of chloroform, which is required to be dissolved in 200 ml of the alcohol, so that we can get the resultant solution where the percentage strength will be 5% in whole total of the 200 ml of the preparation. Clear? Similarly, another mode of expression is percentage weight in volume mode, and it is defined as the amount of solute present in gram in each 100 ml of solution, and it is expressed as percentage weight by volume, W by V. For example, 0.9% W by V sodium chloride solution means 0.9 gram of the sodium chloride is present in 100 ml of the solvent. Similarly, if you are going for another example, that is your 5% weight by volume of NaCl, that means 5 grams of NaCl is present in 100 ml of the solvent. Next, coming to the another mode of expression, that is your percentage volume in weight mode, and it is defined as the amount of solute that is present in terms of ml in each 100 gram of the solution, and it is expressed as percentage V by W. For example, 8% volume by weight of solution, that means 8 ml of solvent, 8 ml of solute, sorry, there is a mistake, you can correct it. 8 ml of solute is present in each 100 gram of the solution. Okay. Now coming to the alligation methods, and this method is used when calculation involves mixing of two or more similar preparations of different strength to produce a preparation of intermediate strength. Later on, before going to the alligation method, as we have discussed previously the percentage mode of expression of the solution, here we are considering single strength, 5%, 10%, 20%, etc. But here when you need to prepare a percentage strength solution which contains different strength of the content, but we need to prepare an intermediate strength of the preparation. In that case, alligation method is used, and for calculation of this intermediate strength, the following figure is used. See, this is the figure where there is a stronger percentage which is given, which is resulted by a required percentage minus weaker percentage gives the stronger percentage. Similarly, there is an weaker percentage which is given as stronger percentage minus required percentage, that is the weaker percentage, and at the middle part there is the required percentage is given. By using this figure, we can calculate the intermediate strength of the preparation. For example, calculate the volume of 95% alcohol required to prepare 600 ml of 70% alcohol. Here the percentage alcohol used is your 95%, and the percentage alcohol required is 70%, and final volume of the preparation is volume of the alcohol required is equal to 600 ml. If we are going to put this data into our alligation method figure, it will be this. From this we can conclude that 70 parts of 95% alcohol and 25 parts of water required produces the required percentage of 70% of alcohol. That means quantity of 95% alcohol required is equal to 600 into 70 by 95, that is equal to 442.10 ml, 10 ml, and the quantity of water required is equal to 600 into 25 divided by 95, that is equal to 157.90 ml. Hence 442.10 ml of 95% alcohol when mixed with 157.90 ml of water, it produces 600 ml of 70% alcohol. That is the intermediate strength, which is calculated from the stronger and weaker percentage in between. Similarly, another example is there when we need to calculate the amount of 70%, 60%, 40% and 30% alcohol that are used and produce a 50% alcohol. To produce a 50% alcohol, how much quantity of 70%, 60%, 40% and 30% alcohol should be used? By using the alligation method, we can calculate it that the figure will be this, and from this we can get this parts of 70%, 60%, 40% and 30% alcohol should be required. From this we can calculate the volume like this. When 20 parts of 70% alcohol, 10 parts of 60% alcohol, 10 parts of 40% alcohol and 20 parts of 30% alcohol are mixed together, the resulting solution will produce 50% alcohol, and the volume will be 20 into 70 plus 10 into 60 plus 10 into 40 plus 20 into 30. That will be, we can see, 20 into 70. Similarly 10 into 60 and 10 into 40 and 20 into 30. That will be 1400 plus 600 plus 400 plus 600, that is equal to 3000 ml, that is equal to 3 liter. Hence we can calculate as such. Similarly, next coming to the proof spirit part. The proof spirit, see, for exercise purpose, the strength of alcohol preparation are indicated by degree, that will be either overproof or underproof. So the strength, what will be? The proof spirit is that mixture of alcohol and water which at 51 degree Fahrenheit weighs about 12 by 13th of an equal volume of water. In India, it will be considered as 57.1% volume of ethyl alcohol is considered to be equal to the 100 volumes of proof spirit. That means any alcoholic solution which contain 57.1% volume by volume alcohol is a proof spirit and is said to be 100 degree proof, and any strength above that proof strength is expressed as overproof, and any strength below that proof strength is expressed as underproof, and the overproof can be denoted as O, capital O and capital P, and underproof is denoted as capital U and capital P. In India, the excise duty is calculated in terms of rupees per liter of proof alcohol. How much concentration of alcohol present in a particular solution based on the proof strength. Based on that, we can charge the amount, how much amount that solution will be cost. So any preparation or any percentage volume in volume of alcohol can be converted into proof strength, and vice versa also. We can convert a proof strength into its volume in volume of alcohol form, and multiplying the percentage strength of alcohol by 1.753 and deducting 100 from that product, it will be interconverted. If the result is in positive term, then it will be overproof, and if the result comes in negative term, then it will be known as underproof. See that 1.753, that value comes from that part, 57.1 volume of ethyl alcohol, that is equal to 100 volume of the proof spirit, and 1 volume of ethyl alcohol is equal to 100 by 57.1, that is equal to 1.753 volume of the proof spirit. So if we are using that data to convert the volume strength to percentage strength or proof spirit strength, then that will be considering an example like find the strength of 95% volume by volume alcohol in terms of proof strength or proof spirit. Here we have percentage strength of alcohol is equal to 95, and by applying the formula for calculation of proof spirit is percentage strength of alcohol into 1.753 minus 100, as we discussed previously. So here the percentage strength of alcohol is 95, so 95 into 1.753 minus 100, that is equal to 166.53 minus 100, that is equal to, the result comes in positive term, plus 66.53 degree, that means it's an overproof. So by this way you can calculate. Similarly, calculate the real strength of 30% overproof and 40% underproof. Here the term given in percentage strength, we need to convert it into volume in volume terms. So we can calculate that 30 degree overproof means 100 plus 30, that is equal to 130. We have the formula that alcohol strength is equal to proof strength by 1.753, that is equal to 130 by 1.753, that is equal to 74.15% volume by volume. Similarly, 40% underproof means 100 minus 40, that is equal to 60. Hence the strength of alcohol is equal to 60 by 1.753 is equal to 34.25% volume by volume. That means 74.15% volume by volume alcohol is present in case of 30% overproof, and in case of 40 degree underproof, that will be concentration term will be 34.23% volume by volume of alcohol is present in that solution. Now coming to the isotonic solution. So isotonic solution having the same osmotic pressure, when a solution is having the same osmotic pressure is called as isoosmotic one, and if a red blood cell is placed in a solution that has the same osmotic pressure as that of the blood plasma, then the cell neither swell up nor shrink, that is, it will remain its own tone, and for this reason the solution is said to be isotonic one. Are you got it or not? The solution in which osmotic pressure is same and that osmotic pressure is similar to our blood plasma, and if the RBC cells are placed in that solution and the solution neither in that solution the blood cells neither swell or nor shrink, then the solution is said to be isotonic one, and the solution which are not having the same osmotic pressure is considered as paratonic solutions. Again subdivided into two categories. One type of paratonic solution is hypertonic, another is hypotonic. So when we are comparing a solution with one of the known osmotic pressure, those which exert a greater pressure are called as hypertonic, and those which exerts a low pressure are called as hypotonic one. And in general, blood contains 0.88% of inorganic salts, mainly your sodium chloride, which makes the main contribution to the osmotic pressure. Hence, a solution containing 0.9% of solution, 0.9% sodium chloride is isotonic with the blood plasma and is regarded as standard, and a solution containing more than 0.9% sodium chloride is called as hypertonic. For this reason, it will be called as a hypertonic solution one. and one solution which contains less than 0.9% sodium chloride solution, it should be considered as hypotonic one, as 0.9% sodium chloride in a solution is said to be isotonic. Over that value, it can be considered as hyper or hypotonic. Next is calculation of isotonicity. Based on the freezing point method and based on the molecular weight method, we can calculate the isotonicity. First, coming to the first method, that is the based on freezing point method, how can we calculate the isotonicity of a solution? Based on the freezing point method, the percentage weight by volume of adjusting substances required is given as 0.52 minus A whole divided by B. That is the equation which can be used to make the solution isotonic based on the freezing point way, where A is the freezing point of the adjusted solution and B is the freezing point of a 1% weight by volume solution of the adjusting substance. We can clear it by using the by coming through the example, that is find the concentration of sodium chloride required to make 1% solution of boric acid isoosmotic with the blood plasma, and here is given as freezing point of 1% weight by volume solution of boric acid is minus 0.288 degree Celsius, whereas freezing point of 1% weight by volume solution of sodium chloride is minus 0.576 degree Celsius. And it can be calculated as, we have the formula, percentage weight by volume of adjusting substances required is equal to 0.52 minus A whole divided by B. Here we can put 0.52 minus, that is 0.288, which is your boric acid freezing point of 1% weight by volume solution of boric acid whole divided by 0.576. At the end, we can conclude that 0.402% weight by volume. Okay. Similarly, by this way, we can get that 0.402% sodium chloride that is required to make the 1% solution of boric acid to isosmotic with the blood plasma. So, if we add 0.402% weight by volume of sodium chloride into the boric acid solution containing 1% solution of boric acid, then it will be isosmotic with our blood plasma. Okay. Now coming to the second example, and this will be given as this. We can go through it. From this we can calculate that 0.668% weight by volume of sodium chloride is required to make 1.5% solution of cocaine hydrochloride, which should be isosmotic to the blood plasma. Similarly, based on the molecular weight method, we can calculate that percentage weight by volume of adjusting substances required is equal to 0.03 into capital M whole divided by capital N, where M is the gram molecular weight of the substance and N is the numbers of ions into which the substance is ionized. Coming through an example, find the preparation of dextrose needed to form a solution which is isosmotic with the blood plasma. The molecular weight of dextrose is 180 and it is a non-ionizing substance. Hence, by using the formula, percentage weight by volume of adjusting substance required is equal to 0.03 into M divided by N, where N value is nothing, that means 1, and it will be 0.03 into M. Here M value of M or molecular weight of dextrose is 180, so 0.03 into 180 is equal to 5.4% weight by volume. So 5.4% dextrose is needed to form a solution which should be isosmotic with the blood plasma. Similarly, another example is given. You can go through it, and along with this, assignment number 5 has been completed. Thank you.